So it says evaluate the following double integrals. The good news is the limits of integration are defined for you. So you don't have to draw anything. So just throw in the limits of integration. Now, I suppose you do have to decide. So we have this integran. So before you decide on the order of integration, decide, okay, would you rather integrate with respect to x first or with respect to y first? So think of the inner integral. I haven't put in the differentials yet. But would you rather integrate, yeah, it's an x here. It needs to grow a tail. It needs to devolve. So why x first? Because you have an x outside, which is going to help by using u substitution, right? Otherwise, you got to integrate a square root involving y squared, and it's not going to be easy to do, is it? So long story short, integrate with respect to x first because it's going to be easier to do, or it's going to be relatively easy to do because you can use a u substitution. So that means dx dy, and then we have to look at the limits on x 0 to y, so those are your inner limits, and the limits on y 0 to 1. Okay? Does that setup make sense? So there was a little bit of thought involved. You had to think which order of integration is going to be easier. And so you're not going to go to the default dy dx because integrating with respect to x first is easier, so it's dx dy. All right, so if we want to integrate this, and you thought in terms of u substitution, what would u be equal to? Y squared minus x squared. That's your u, and then what would du be equal to? Negative 2x dx. Okay, so if you like rewriting it so you can see your perfect du, I'll do that for you. We'll make this the square root of y squared minus x squared in front. Then we have x moving, this is just multiplication, so I'm just changing the order of multiplication. Dx and then dx dy. What do I need in front of this x to have my perfect du? Negative 2. So put in a separate set of parentheses, otherwise it looks like subtraction there. And then what do I have to compensate by? Multiplying by negative 1/2 out in front. Everybody with me? So what does this integran really become then? It's what? The square root of u du on the inside, right? Which is u to the 1/2. Okay, so let's see if we can figure that out. So integrate the square root of u, which is u to the 1/2. The other symbolism doesn't go away. What do you get? 2/3. Oh, you want to write that out front? Here's what I like. Okay, let's. So, well, I'll show the 2/3 though. So 2/3 out in front. That comes from flipping. Okay, so what do? It's u to the 1/2. So you add 1 and get 3/2. So you flip that and multiply out in front by 2/3, right? That's where that's coming from. And then, so then the guy left inside is y squared minus x squared to that's the 3/2 power, right? And then evaluated from what to what? 0 to y, and then we still have the dy out here. Does everybody buy that? Yeah? Okay, so we have negative 1/3 out front, integral 0 to 1. Okay, what does this guy become when you plug in? Okay, what are we plugging in for? This is x equals y, right? X equals y, x equals 0 to x equals y. So what happens when you plug in y for x here? You get 0, so I'll write that down. 0, and then because you get y squared minus y squared, right, to the 3/2. So technically it's 0 to the 3/2, but we're not going to worry about that. And then minus, what happens when you plug in 0 for x? You get y squared to the 3/2, which is, so minus y cubed. Would you buy that? And then dy. Everybody buys that? Okay, bring out the negative. You get 1/3 integral 0 to 1 of just y. Oh, that's not so bad. Y cubed dy. Integrate. What constant goes out in front? So you get 1/4 y to the 4th when you integrate. So bring that 1/4 out front. Oh, and it's just from 0 to 1. So that part just becomes 1 to the 4th, right? So, or 1, yes. And then 1/4 times 1/3 out front. So 1/12. There you go.